evaluate what should be the effective span of the slab. So here you can refer clause number 22.2. Again, same clause which we have referred in case of design of beam. So first of all, let us discuss how to assume or how to take the width of the slab. So for design calculation, as I have already discussed, width of the slab is taken as 1000 millimeter. That means 1 meter width will be taken. So that means what we are going to design, when you have to design the slab, uh, then you have to take a strip for the design, and that strip of slab having width 1 meter. Now next step is the effective span of slab. How to get the effective span? So you can see here there is a slab, and that slab is supported on the two walls. So that means it is a simply supported type of slab and having clear span length LC and center to center support distance. Uh, this will be the center to center support distance. Now if it is a simply supported slab, as you can see in this diagram, then slabs that are not built integrally with the support. That's why we are saying that it is a simply supported slab. So such type of slabs supported on generally on brick walls. So very first condition is effective span length is equal to LC plus LD. LC you can see here it is the clear distance or clear span length between the face of the two supports. And D will be the effective depth or thickness of the slab which we are going to design. Then second is center to center support, and again we have to take whichever is the lesser value, and as we discussed LC the clear span between the support and D is the effective depth of the span. So this formula or this condition is valid when it is a simply supported type of slab. Now if it is a continuous type of slab having more than one span, just like this, so there may be having number of spans. They may have a equal span length or they may have different type of span length, as well as width of support we can say it is BW. So this type of slab which we are going to design, first of all, since this slab is ending at this support, so we will term it as end span. So that means this particular span is end span. If I take that this is the end span, and the other span will be the interior span or intermediate span, depending on how many spans are there. So first case, as already given in the IS 456, if the width of support is less than LC by 12, then effective span length is equal to LC plus D or center to center of the supports, whichever is lesser. Now case number 2, if the width of support VW is greater than LC by 12 or 600 mm, whichever is less, then we can say for end span. Now you can see this is end span. If you are going to discuss this span, that means you are going to design this span of the slab, where one end is it may be fixed and other end may be continuous. Here if one end is fixed, now earlier we have discussed simply supported, now it is a continuous type of slab. Here there may be a fixed type of support also. So both the possibilities are there. If it is not a fixed type of support, then first condition will be easily applicable, and for end span with one end fixed and other continuous or intermediate span, then L effective will be equal to length of the clear span, and for end span with one end free and other end continuous. Now if this is the first case, if this end is not fixed, that means this end is free, simply supported, and other end is continuous. So this will be the continuous end, this will be the free end in case of if it is placed on the walls. So then you have to take note of this particular step number 2, and accordingly we have to find out what is the effective length of the span. And the third one again, which we have already discussed in case of beams also, span with the roller or rocker bearing, then L effective will be distance between the center of the bearing. So by this step we will be able to work out what will be the effective span of the slab based on the various type of end conditions and based on the width of the